Okay, we're on 5.5 graphs of relations and functions. So we're going to identify whether a graph represents a function, and the way we're going to do that is a handy dandy thing called the vertical line test. So you'll want to whip out your ruler like I have mine here, and what you're going to do is you're going to take your ruler and you're going to move it along just like this, vertically. Good. So there's only one dot there, so right now this is a function, and at this point, right here, not a function. And that is because we have two dots that intersect on the same line. So that was like when we were looking at a table, if there was more than one value, if we were looking at an ordered pair, and the first pair, the left part of the pair, the independent variable had more than one size. So this says at size, like, I don't know, 8.5. There's two different variable heights, which isn't very useful for us. Okay, so let's check this guy. Is this one a function? And we pass through. Yep, 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 yep. He's a function. And it's that simple, vertical line test. Take your ruler, slide it along the graph. Determining the domain and range of the graph of a function. So these are functions because they pass the vertical line test. So the domain, remember, is the independent values, so our x values. So what we can do here, I'm going to use the ruler again because I think it's really nice to iterate what's happening here. So if we look at this, x can exist anywhere in here. All of these x values that I'm sliding across work, but I stop here. Past this point right here, my x values do not continue. But I can be anything to the left of that. So all I know is that x exists, but it's gotta be less than or equal to 3. Because it could be 2, it could be 1, it can be 0, it can be any of the ones along here. And I'm going to get rid of those circles. Now my range are all of my y values, my dependent values. So then if I kind of use that same mentality, that same line, so we're going to unlock this, and we're going to rotate it somehow. How did I do that last time? I'm going to pause. All right, so the ruler's rotated. So if I check this, stop, and I start here, this is my lowest value of y, and it goes up, 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 and I have a stop point on the right-hand side, but it still keeps going up. So my only stop point is down here. But it's not even a stop point. It's just saying that this is the smallest value, and I'm going to change my color here. Sure, let's change it to purple. That is the smallest value that y can be. So my range is such that y must be greater than or equal to -1, because it could be here, but it just keeps going up. None of these values get interrupted. Okay? So then let's think about this guy, our domain. I don't know how it does it, but it does it sometime. There we go. Okay, so then if I'm looking here, I have an x value that occurs here. Let's use blue. And then if I continue along, dun, 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 I have another stop point right here. So that tells me that my x values are only going to exist within these 2 points. So x has to be greater than -2, but also less than 2. If I look at my range, clicking. It's not clicking with me. There we go. Flip. And bring it back. So then this is our smallest value of y. It exists right there. Then if we move this up, up, we have another containment here. So then range 0 less than or equal to y less than or equal to 2. So it's all about, dragging and dropping your ruler if you can. Sometimes it's kind of tricky. And identifying which values exist within our range and our domain. So determining the domain and range and graph of a situation. So this graph shows a number of fishing boats anchored in an inlet as a function of time. So the dependent variable is little t. Independent. And n is dependent. Why are these points in the graph not connected? Well, the number of boats has to be whole. We cannot have half a boat. We cannot have 3/4 of a boat. We cannot cut the boat in half and still have a full-size boat. The domain of this graph is 9, 10, 11, 12, 13, 14, 15, and 16. Curvy braces. And the range of this graph is 6, 8, 10, 11, 15, and 25. Okay, let's do this next one. This graph shows the approximate height of the tide as a function of time. On June 17th, identify the dependent and the independent variable. The dependent variable is h, and the independent variable is t. The points in the graph are connected because we can have 0.9 of a tide, 1 point of a tide. So we can essentially, we don't need whole values. The domain of this graph, because the points are connected, we don't have to list them out. So this exists between 9 less than or equal to t less than or equal to 16. The range 0.9 less than or equal to h less than or equal to 1.5. And our last one, determining domain and range values from the graph of a function. So we have our function notation. F of x is equal to negative 3x plus 7. Determine the range value. So range value, we are looking for dependent, or y, or f of x. When the domain value is negative 2, so that says f of negative 2 is equal to negative 3, bracket negative 2 plus 7. 6 plus 7 is equal to 13. Let's check. So at negative 2, go up, 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 boom. That looks like it's about 13. Determine the domain value when the range value is 4. So remember, this is saying f of x is equal to 4. So 4 is equal to negative 3x plus 7, subtract 7. Negative 3 is equal to negative 3x divided by negative 3. 1 is equal to x. So let's check that. If we are at 1 is equal to x, so if we go up to 1 and up, 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 4. Perfect. Done and done. Just remember that domain value, we're solving for x. Range value, we are plugging in numbers.